Hello, my name is Accensi, and today I'm going to be talking about software-defined radio. Software-defined radio is a software that allows you to decode radio signals. We can use that in order to communicate or receive radio from satellites, such as the ISS, meteorological satellites, or we could even use it here down in Earth to actually listen to the radio. In this tutorial, we're going to focus into LEO satellites. There are three types of orbit or satellites. They are the LEO orbit, which is low Earth orbit, the MEO orbit, which is the middle Earth orbit, and the GEO orbit, which is the geostationary Earth orbit. In this case, we're going to only be focusing to LEO orbit, because it contains the easiest to receive satellites and the cheapest ones to start with. Some of the satellites that this LEO orbit contains are the meteorological satellites, such as this one, or the ISS that we all know, and it orbits between 360 kilometers. One thing I forgot to mention is that LEO orbit is between 200 kilometers to 2000 kilometers. In order to receive these signals, we need an antenna and a chip and a special USB dongle that contains this chip. This chip is called RTL2832U, and it allows us to decode from 50 to 1700 megahertz. The other component we need, and which is very important, is the antenna. In this case, this is called a J antenna, and we need to make it ourselves or buy it, but it is considerably easy to make, and we need to make specifically for each frequency. Each frequency or a small range of frequencies needs a special or a specially cut size of the antenna. In this case, this is what we're going to be talking about today. They are called SDR, and they are the actual programs to listen to this radio. As you may know, I am recording this with a Macintosh, so I'm going to be using Cubic SDR, but there is also SDR Sharp for Windows. They are both free source software, open source programs, but there are many more on the internet, and they all work pretty much the same way. Now, before actually opening the SDR, we need to plug in the dongle. We need to do that before opening the program, because if not, it will not recognize it. Once we open it, we receive here several devices we can use in order to start recording, and we logically use the one that has the RTL2832 chip. Once we start recording, we can already see that we are receiving some signals. In this case, we're going to be explaining all the parts that this software has. From the top left corner, we can see several types of modes we can use. Usually, if you'd like to listen to the radio, I would suggest using FM. For everything else, I usually use AM because it has a cleaner sound, and it is more clean and more it reduces the actual noise. If we want to start listening what we're receiving right now, we can check what frequency we are pressing the space bar, and we can see right now we are at 100.18 megahertz. That could perfectly be a radio station from here down to Earth, and if we press here, if we select, as you can see, if I move the cursor, I can start selecting to a dedicated area, if I press, I can start listening to what they are saying. As you saw, I muted the audio with M because sometimes it can be a little bit annoying. Here in the left part, we have several options. We can see what's the active frequency, the same way we pressed the spacebar. We can see some ranges we can select and the actual frequencies they are placed on. And we can see what the recent frequencies are. For instance, if we want to record what a remote command is emitting, we can use this frequency, which is, it's not 33.94, it's 433.94. So it has a little bit of error. We can select this and we can edit this using this. As you can see here, we can add frequency, we can decrease frequency very precisely. And as you can see right now, we are in this frequency. As I said, these frequencies are usually used for remote controllers. So for instance, if I press a remote controller I have with me, you can see that it produces a signal. Right now I am in AM mode, which I said it is one of the cleanest. And again, if I press the button, you can see we're receiving some signals. If we want to receive the ISS, as I mentioned before, it is located in 145.08. And actually, of course, right now we won't be able to listen it because, first of all, I don't have a J antenna installed, and second of all, and most important, I don't have the ISS is currently not passing over my region of space, but I can use prediction models and prediction programs in order to do that. And if I had this program and the antenna, I would be perfectly able to actually listen to what they're saying and listen to what they're emitting. This is a very powerful program that we can use not just to listen to the meteorological satellites, but we could also use it to intercept walkie-talkies and learn a little bit more about how these electromagnetic waves work. Once we have selected the region of frequency we want to use, we can record what we are listening. Going here, we can set a recording path, and once we have set the recording path, we can start recording. Right now, it won't let me because I don't have a set path, but we could perfectly do that, and we could record that audio and save it for later. Well, this has been my tutorial. As you can see, software-defined radio is a very simple tool, but at the same time is a very powerful tool we can use to start learning and start working with satellites and other type of radio technologies. Thank you for listening to me.